We're continuing working through the AB Fall multiple choice review. This is problems 45 through 49. For questions 4 through 46, the motion of a particle in a straight line is given by x of t equals t cubed minus 6t squared plus 12t minus 8. This is a carryover from the last page. So our velocity we found was 3t squared minus 12t plus 12. So 45, the acceleration is positive when, so we need to find acceleration by going one more derivative down from velocity. So 3t squared becomes 6t, 12t becomes 12. We set acceleration equal to 0 to find out that critical value. We put it onto our sine line, and then we test each interval. If we plug 1 into acceleration, we get 6 minus 12, which is negative. If we plug 3 into acceleration, we get 6 times 3 minus 12 is positive. So based off of this, we see acceleration is going to be positive to the right of t equals 2, to the right of 2. 46, the speed of the particle is decreasing when, based off of the previous sine line, we see that velocity is increasing on either side of 2. For acceleration, we see negative acceleration and then positive acceleration to the right. So speed is going to be decreasing where signs are different between acceleration and velocity. And speed is going to be decreasing from negative infinity to 2. So we see that none of the answer choices fall under that category. So E, none of these. 47. A circular cone reservoir, vertex down, has a depth of 20 feet. So given by notated here. And the radius is 10 feet. Okay, not the diameter, just the radius is 10 feet. Water is leaking out so that the surface is falling at a rate of 1/2 feet per hour. So surface is falling. In other words, the water level is dropping. And the water level is dropping. That is referring to the height or the rate of change of the height of the water level. So we can represent this as dH dt. And because water level is dropping, we can say it's decreasing over time. The height is therefore decreasing over time. So we can say dH dt is negative 1/2 feet per hour. The rate in cubic feet per hour in which the water is leaving the reservoir when water is 8 feet deep, so 8 is referring to the height at this particular moment, and we're trying to figure out the rate at which water is leaving. Well, water is volume, so cubic feet per hour, so we're looking for dV dt. Okay. So if we consider the equation for volume of a cone, we know that we don't have enough information to account for all these variables. But because we have a cone and we have similar triangles, we can represent radius in terms of height or height in terms of radius. And because we're given information about height, let's go ahead and convert everything to be in terms of height. But first, let's set up a relationship between radius and height. So this is R represents the radius of the water level. Height is the height of the water level. 10 is the radius of the container, and then 20 is the height of the container. If we set up using similar triangles, proportions, we can say radius, small radius is to big radius, R is to 10, as small height is to big height, H over 20. If I do cross product, I get 20R is equal to 10H, and if I solve for R is 1/2 H. I want to try and rewrite this equation in terms of height. That way I can find the derivative and get dH dt to show up. So I'm going to replace R with H over 2. Okay, so 1/2 H is the same thing as H over 2. So plug in H over 2 in for R. We also have to square that, so H over 2 squared. We're going to try to clean this up as much as possible before we find the derivative. So H squared over 2 squared is H squared over 4. Multiply all the numerators together. I'm going to pull out the coefficient. So 3 times 4 is 12. Pi over 12 is the coefficient. H squared times H is H cubed. We can find the derivative. okay, which is 3h squared, or sorry, v becomes dv dt. Pi over 12 coefficient stays. H cubed becomes 3h squared dh dt. Remember, with related rates, we have to attach a d over dt after each variable, since time is the time is the independent variable. So now, from here, we can now plug in 8 in for h, because we want to find, we don't want to replace 8 in for h before we find the derivative. So we had to make sure that we held on to this variable until after the derivative was found. So we found the derivative. Now we can replace h with 8. So we get power 3 over 12 is pi over 4. 3 over 12 is 1/4, so pi over 4. H is 8, so 8 squared. And then dh dt is negative 1/2. We multiply everything through. We get negative 8 pi. And then we say cubic feet per hour. Okay, 48. Two cars are traveling along a perpendicular roads. Car A at 40 miles per hour. So A is car B at 60 miles per hour. Okay. At noon, when A reaches the intersection, car B is 90 miles away and moving towards the intersection. Okay. At 1 p.m., the distance between the car is changing in miles per hour at a rate of. Okay. So the car A had, when it reached the intersection, car B is still a ways away, but car A is still continuing moving in the same direction. So I had car A moving north, and then I had car B moving east. And now I'm going to let y represent the vertical distance of this triangle, x represent the horizontal distance, and z represent the hypotenuse, the distance between the two cars at any moment. And we know dy dt, the rate at which the car A is moving, is 40 miles per hour. Dx dt, because of the way that this triangle horizontal length is decreasing, we're going to make that a negative rate, so negative 60 miles per hour. Okay. When car A reaches the intersection, car B is still 90 miles away. 1 hour, at 1 p.m., which is 1 hour after 12, we know that since car A is moving at 40 miles per hour, we know that 1 hour later, it'll be 40 miles away from the intersection. Okay. For car X, or car B, is moving at 60 miles per hour. So after 60 miles away at 12 noon, so at 1 p.m., 1 hour later, it would have traveled another, it was 90 miles away. So 90 miles away at noon. So 1 hour later, after it travels for another 60 miles, so it would have covered 60 miles from 90, so 90 minus 60 would be 30, so this distance, so that means 1 hour later, even though it started at 90 miles away, 1 hour later would have covered 60 miles and would only be 30 miles away from the intersection. So we have 40, 30, and then Pythagorean theorem will get a z, which is 50 miles. So now we're trying to find the distance between the two cars, so dz dt. We start off with Pythagorean theorem, x squared plus y squared equals z squared. Find the derivative with respect to time. So x squared becomes 2x dx dt, y squared becomes 2y dy dt, z squared becomes 2z dc dt. So now we just plug everything in. 30 in for x, 40 in for y, 50 in for z, 40 in for dy dt, negative 60 in for dx dt. Combine terms. Try to solve for dc dt. So negative 400 equals 100 dc dt. Divide both sides by 100, we get negative 4. So the rate of change of distance between the two cars is negative 4 miles per hour at this moment in time, at 1 p.m. 49. Which statement below is true about the curve of x squared plus 4 over 2 plus 7x minus 4x squared? Now, all these statements are about vertical asymptotes and horizontal asymptotes. So let's just go ahead and just find that information from this equation. Now, horizontal asymptote is the same thing as evaluating the limit as x approaches infinity. So if it's approaching infinity, we look at the degrees and we see that the highest degree is x squared in the numerator. The highest degree in the denominator is also x squared. So if the degrees are the same, then we just take the coefficients. So 1x squared over negative 4x squared, the coefficient is negative 1/4. So that's our horizontal asymptote, y equals negative 1/4. To find the vertical asymptote, we have to look to see what factors are in the denominator. So I'm going to try to factor the denominator here. I'm going to rearrange, putting the highest degree, try to write this in standard form here. So highest degree first, negative 4x squared plus 7x plus 2. It'll be easier if I can have a positive value for factoring. So I'm going to pull a negative out and change all the terms inside. So 4x squared minus 7x minus 2. If I factor this, I get 4x plus 1 times x minus 2 with a negative outside. And there are no factors that cancel out, so both of these factors would be where vertical asymptotes will occur. So if I set 4x plus 1 equal to 0, I get negative 1/4. If I plug x minus 2 equals 0, I get x equals 2. Now this negative 1 is not going to affect anything, so it's basically negative 1 is just a coefficient that just goes away. We just focus with what's inside these parentheses. So if our vertical asymptote is negative 1/4 and x equals 2, the only answer choice that's going to be true will be x equals negative 1/4 vertical asymptote. X equals 1 is vertical asymptote, that's false. Line y equals 1/4 is not a horizontal asymptote. The asymptote is actually at y equals negative 1/4. The graph has no vertical or horizontal asymptotes. We know that's false because we found 1 horizontal and 2 verticals. And the line y equals 2 is a horizontal asymptote. That's also false because the only asymptote that we have for horizontal is y equals negative 1/4.